All right, so we're just going to take a look at a few factoring problems for those of you who don't remember the process per se. All right, but basically factoring, what we're trying to do is break up our polynomial here into its respective factors. Keep in mind, as we're talking about factors, 2 times 3 equals 6. 2 and 3 are factors. Okay, when we're talking about an algebraic expression, if we have 2 times x plus 3, that's going to be 2x plus 6 is the polynomial. Okay, so you can kind of see what we're trying to undo is we have this expression. We're trying to work back into a product of two factors. Okay, and how we do that is follows. So I'm going to look at this very first example here. Notice my leading coefficient is 1. How we're going to start the process is we're going to take our leading coefficient and our constant and multiply them together. So whether it's on your paper or in your head, you're thinking of what are the factors of 42. Well, I have 1 and 42, 2 and 21, 3 and 14. Just kidding, 4 is not one of them. 5, no, 6, and 7. And then we're going on from there. And that's it. All right. So those are a list of factors. The goal is to figure out which factors give you a sum of 13. Well, it's not 1 and 42. It's not 2 and 21. It's not 3 and 14. 6 and 7. So what I'm going to do is I'm going to take this 13 and I'm going to break it up into 6v and 7v. The other portion of my expression I'm going to leave exactly as is. And then what you're going to do is we're breaking this up into two smaller problems. All right, and I want to think undoing my distributive property. So what can I take out of both of these expressions? Well, I can take a v, and then what's left is v plus 6. What can I take out of this expression? Well, I can take out a positive 7. And then if you notice, v plus 6 is also left. When you factor correctly, those are going to be the exact same thing. Notice we have two factors now in this case. We have v and v plus 6. We have 7 and v plus 6. What I can do is factor those out again. So we have v plus 6 and v plus 7. If I were to FOIL and distribute everything back out as a check, I would get back to v squared plus 13v plus 42. That's assuming I did it correctly, which I did. V squared, 6 and 7v is 13v, 6 and 7 is 42. So it worked out correctly. All right. How things change, if we kind of slide down, we're going to grab a different one here. Let's see. Let's do number 7 here. All right. Just kidding. I'm trying to think. Let's actually do number 9. Sorry, I'm just trying to reevaluate problems here as we go through. What makes the most sense? Probably number 9. That will give us the most bang for our buck. So when we're factoring, the first thing you want to do each time is see if you can take out anything that's common between each of them. Okay. So I'm going to take out a b first. Now I'm left with 7b squared plus 38b plus 15. Okay. Then we do the exact same process as before. So I'm going to take my leading coefficient and my constant, and I'm going to multiply them together. 7 times 15 is 105. Okay. So I'm thinking, what are the factors of 105 that give me 38? Well, I have 105, I have 3, and 35. I have 15 and 7, obviously. And that's it. All right. So looking, those don't work. Those don't work. 3 and 35. Keep in mind, if this were a negative, you'd want to figure out the combination that gives you a negative. All right. So in this case, I want to break this up into 3b plus 35b, because that's 38b. I still have my 15. I still have my 7b squared. Then just like before, I'm going to break it up into two smaller problems. Out of this one, I can factor out a b. So I'm left with 7b plus 3. In this next one, 35b and 15, I can take out a 5. And then I'm left with 7b plus 3. Exactly what I was supposed to have, because notice, those match. So I can factor it again. So I have 7b plus 3. I have my b plus 5. And then remember, I have that original b out front. Okay. Some problems may not start with 3 terms. Some may only have 2. So in this instance is number 12. We just kind of look down. What can you take out from both of those? The common term is b. I'm left with 7b minus 3. And that is the extent of that problem. So those two for ones are pretty straightforward as far as things go. Let's do one more for good measure. All right. As I'm continuing on, obviously numbers get bigger and bigger and bigger. Actually, let's do 15, just because again it's a two-term expression. So we're going to factor out what's common. In this case, we have a 4n squared, which is common. We're left with n minus 8. Okay. Again, take out what's common, make your life easier. I think that probably does it for things. But maybe let's do a negative one, huh? Sorry, I'm just trying to think on the fly here what problems would be good. We have those ones down there. We have that one there. 2872. Let's actually do number 10. Okay. So looking at things, what can I take out before I start the factoring process of each of these terms? It looks like I can take a 4 and an n out, which means I'm going to have 7n squared minus 18n minus 9 to start, correct? And if we distribute back in, we get 28n cubed. We get negative 72n squared minus 36n. Just like before, we're going to take our leading coefficient and constant. We're looking at 63, so we're looking for factors of 63 that give us negative 18. So we have 3 and 21. We have 7 and 9. So again, I'm looking for a sum that's negative 18. Those won't work, but those ones do. So if I have negative 21n plus 3n, that gives me negative 18n. And then like I said before, we're going to leave the first and last part there. The 4n stays out front. Then we can break it up into two smaller problems. What's common in my first group? 7n. N minus 3 is left. What's common in my second group? 3. So I have, n minus 3. If you notice, we pick the numbers appropriately because those are the same. So we have n minus 3. We have 7n plus 3. And then we have our 4n out front. All right. So that's kind of a mini lesson review on factoring. The process, what we're doing, again, we're looking to undo that multiplication, undo that distributed property. But again, the big thing is you're trying to find those numbers that work. In this case, it was 63. We want to figure out the factors that work to give you that middle sum. This process, what we did, is called grouping, if you need to look it up online for additional practice. Otherwise, post to the discussion board or find me at a live session for additional help. Best of luck on factoring. It's only 20 questions, and I just did 5 of them for you, so hopefully it shouldn't take too incredibly long. That is all.